Name's Robert Nichols, mechanical engineer over here at Channel Island Surfboards, in charge of our CNC facilities. This is a custom one-off specific surfboard shaping machine built from the ground up. This is called the cybernetic shaper. We've had this machine in our hands for over a year and a half now. It was as easy as just getting a moving company to move it in and place it in the correct spot where its home was going to be for many years to come. Most CNC machines do have a specific tool used for cutting surfboards, but ours is about 10 inches in diameter. That sets it off. You can reduce the amount of passes that it takes to actually machine the board, so it takes less time. The cutting tool is made out of steel. The cutting surfaces themselves are carbide inserts. These are found a lot of times on CNC cutting tools. Those are used for the wood cutting portions of it. Around the outer surfaces, there's actually a diamond grit adhered to the steel tool itself. And that diamond grit itself is the one that's doing the cutting on all the foam. It's almost like taking sandpaper, like as though you were going to be shaping it. It just spins around and sands off all the foam. Tied in with that is the fact that it's 5-axis. Allowing it to move in all different directions allows us to achieve those shapes that we desire. The CNCs run off of coordinates, so an axis is a direction that the machine is moving in. But pretty much it's a forward-back movement, an up-down movement, and a side-to-side movement. Now we have 2 extra ones in there. We have like a B and a C axis, and those are rotation axes. So you can actually spin the tool around in a circle and then wrap down underneath certain curves of the board. It just allows for more freedom and more movement of your cutting. There's the design aspect of the rider and the shaper and their ideas. So verbally, that's usually communicated to me. Numerically also, there's a lot of measurements, as you know, involved by most shapers as far as calipers, thicknesses, and rockers of that sort. I take that information and use a CAD software. Inside there, it's a matter of manipulating what they call control points, and these actually control all the curves of your surfboard and the surfaces themselves. Once that file is created, that's a 3D surface of the surfboard itself. So you import the CAD file that you designed, and then run it in your CAM software, and it creates a numerical alphabetical code. And that file is then transferred to the machine, and it runs off of these coordinates that you've output. Right here in our facility, we actually have all our computers hooked up to a network. So any design work that I do upstairs on the computer, I can immediately transfer downstairs, and the CNC machinist can access that information and upload a file and cut whatever board we may please. Compressed air runs a lot of the systems within the machine itself. The door opens up on compressed air. All the suction cups are run off this compressed air. They actually move based on this air pressure. And then we also have a vacuum pump that runs and provides us with the suction to actually restrain the board down. If you hold that board in the same spot every time, you'll get the same exact board every time you run that same file. Once it comes off the machine, it's sent to a shaping room, and then it's in the shaper's hands to spend whatever amount of time is needed to actually finish shape those boards. So the finish looks really good. You probably could surf it, but there's definitely some more work that's involved. From start to finish, it's approximately 15 minutes to machine a board. Our scrap rate's really low, and it's usually based on like a bad blank, a second blank. If there's any bubbles, or if the foam is crystally, or there's any debris in it, that's usually the reason for a reject. I'm just a computer designer. I'm able to take the ideas that a shaper may have and translate that into a file on the computer. And then maybe as I become more knowledgeable, I may work more in the design in the computer. But right now, I just facilitate ideas and transfer that to being able to be cut on a CNC machine. Day to day, there's a few cleaning procedures as far as keeping the tool sharp, keeping the tool clean, and keeping the dust accumulation down. If you've been in any shaping environments, you've seen the amount of foam dust that accumulates. We got a lot of big machines out in the back, and their main job is just to be keeping foam out of the factory and keeping it outside, stored in barrels. Safety is definitely a #1 issue. And there's a few fail-safe things that are on the machine to keep from happening. The biggest thing is that this machine's entirely enclosed. So it keeps your hands away from those moving parts to keep you from getting harmed or injured while running a machine of this sort. As far as the way that CNC machines go, you just need an operator to be loading in your materials and pressing the button to run the code. So realistically, to get your value out of the machine, you'd like to be running it 24 hours a day.